In this video, we want to find the real solutions for each of these two equations. Now, sometimes I'll ask you to solve the equations by writing them in quadratic form, using a substitution, say a U-substitution. So I'm going to do this problems both ways. You pick your choice. Sometimes a U-substitution can give you a better perspective of the problem, but you can decide on that. I'm going to let u equal to x to the third. Quadratic form, so u squared would give me, squaring both sides here, x to the 6. Now make the substitution. So u squared is x to the 6. So instead of x to the 6, I put u squared. And then plus 7. And x to the third, that's your u. You get minus 8. Equals 0. Now we have a quadratic equation in the variable u. See, the original equation is a 6-degree. It's not quadratic. But we have this one in quadratic form. So we can factor it in terms of u and say this is going to be u plus 8 and u minus 1. And then we solve for u. So we set each factor equal to 0. Product of two factors is 0. That means 1 or both factors are 0. So 8 plus u, or u plus 8 can be 0. Or u minus 1 can equal 0. So we solve each equation here for u, take the 8 over, adding negative 8 to both sides, we get u is equal to negative 8. The second one, add 1 to both sides, we get u is equal to 1. So the solution for this one is u equal to negative 8, u equal to 1. Now you do this kind of thing in advanced courses, also in, say, calculus. You're dealing with integration, but you always have to solve for the original variable. So now u, of course, was x to the third. So I said x to the third then has to be negative 8. Take the cube root of both sides, we get x equal to negative 2. And over here then, x to the third equal to 1. Take the cube root of both sides, we get x equal to 1. And that's your solution for this one. We want only the real solutions. Let's clear this one now. And well, let me do this first now. If I don't use the u substitution, I can factor this into x cubed plus 8 and x cubed minus 1. And then I set each factor equal to 0, and of course I'll wind up with the same thing. So I'd get x cubed is equal to negative 8, x cubed is equal to 1. So again, I would get the solutions for x equal to negative 2, x equal to 1. Now you're thinking about this particular factor right here. This can be factored. Difference of cubes, so this would be x minus 1. Then this would be x squared plus x plus 1 equals 0. And then from this factor here, I would still get x equal to 1. But then this is a quadratic right here by itself. So normally we would expect two solutions. So let's see, it doesn't factor. So what would happen if I use the quadratic formula? X is equal to minus b, a is 1, b is 1, c is 1, so this would be minus b, b is 1, so it would be that, plus or minus the square root of, and then this would be b squared minus 4ac. b is 1, so that would be 1 minus, and this would be 4ac. a is 1, c is 1. This would be 1 times 1. And this would be down here 2 times a is 1. But the problem with this is that here we would have 1 minus 4, this would be a negative 3. So I would get two more solutions, but they would be imaginary or complex, non-real. And it's asking for the real solutions. And that's why the solution was negative 2 only and 1. Now for this one, again I'll start off with the u substitution. U equal x to the 1/4. U squared then would equal to, if I square this, it's multiplying by 2, that's x to the 1/2. So now you can see then I have 4 and x to the 1/2, that'll be u squared. So I'm writing this equation in quadratic form in terms of u. That'd be minus 9, and then x to the 1/2, that's your u, plus 4. And then I try to solve this, it's quadratic in u, by factoring or some other method. This one doesn't factor, so I'm going to use the quadratic formula. So quadratic formula, then the variable, in this case we're dealing with u, is equal to minus b, and b is negative 9. So if I minus that, that's a 9, plus or minus the square root, and then it's b squared. The b is negative 9, so if I square that, that's an 81. And it's a minus 4. That's part of the formula. A is 4, and C. This is 4, AC. C is also 4. That's over 2 times A. A is 4. So this is going to equal then to 9 plus or minus. And this is 81 minus 4 times 4 minus 64. This is the square root of 17. That's over 2 times 4, that's 8. So U is equal to either 9 plus the square root of 17 over 8, or 9 minus the square root of 17 over 8. So we'll set it up this way. I know what U is though. U equals x to the 1/4. So here's where I make my substitution back. So I can solve for the original variable. So I got x to the 1/4 can equal to 9 plus the square root of 17 over 8. Or the other possibility is that 9x to the 1/4 could equal to 9 minus the square root of 17 over 8. So here's what we have then. X to the 1/4 equals to this quantity. So to solve, I take both sides to the 4th power. That'll cancel the 1/4, just give me x. So that'll give me x will equal to 9 plus the square root of 17 over 8. And that's to the 4th power. So that's one possible answer. Or x to the 1/4 could equal to 9 minus the square root of 17 over 8. So again, do the same thing with that. And x can also equal to 9 minus the square root of 17 over 8. And this is to the 4th power. So I took this equation, took both sides to the 4th power, and then the x to the 1/4 could also equal to this value. Again, both sides to the 4th power. And these are the 2 possible solutions that I get for this one. So if it makes it easier for you when you're solving these types of problems, one option you have is to use a substitution. In this case, I use the U substitution. Thanks for watching. We'll see you next time.